This is an electrolytic capacitor. Electrolytic capacitors generally have a large capacitance. We usually use them in circuits for decoupling, or in low-frequency circuits for filtering, or to store energy. This is the casing of an electrolytic capacitor. There is a lot of information about the electrolytic capacitor on the casing, including its voltage rating, capacitance, operating temperature range, and brand name. Additionally, there is a marking on its casing, a white stripe. This trace corresponds to the negative pole of the capacitor. We often use it to identify the positive and negative poles of the capacitor. Now let's first remove its cover. After removing the cover, we have this. The white part is its casing. Its casing is actually made of aluminum alloy. And here is a marking, which is actually an explosion-proof pattern for preventing explosions if the capacitor short-circuits or overheats. That means it will not explode outward. It only explodes forwards from its trajectory. This is the design method of electric fusion. Just grasp the idea. Now we will start to disassemble it. We start from the bottom. Cut open the capacitor. This aluminum alloy shell is not very hard. It's definitely easy to cut off. Then, we can take it out. This is what the exterior of it looks like. And then, there is a black pad underneath. The pad is quite thick, and it is actually an electrically insulating layer, made of phenolic resin. Its function is to seal the electrolyte inside. We will now dismantle the electrolyte inside. Make a cut. As you can see, it is like paper, but in fact, it is the electrolyte. And then, you can see this is the aluminum foil. This is the aluminum foil. However, this aluminum foil has two layers. This layer is a bit thicker. And then inside, there's another layer. And it's also surrounded by electrolyte. This layer is thinner. Then, we continue to dismantle it one by one. We will find that the thicker aluminum foil is in contact with the positive electrode of the capacitor. And the thinner aluminum foil is connected to the negative electrode of the capacitor. There is still more inside it. Let's continue downwards. Let's remove this aluminum foil first. Then, let's go further downwards. As you can see, it is the same as before. It also has two layers of aluminum foil which are actually connected to the previous layers. However, it's still the same. The thicker layer of aluminum foil is connected to the positive pole, and the thinner one is connected to the electrolyte in the middle of the negative electrode. It plays a role. It is for insulation. This electrolyte is moist simultaneously. There is electrolyte adhesive on it. It has a corrosive and irritating odor. This is what it looks like after disassembly. It's pretty simple.